Hello, here's the question number 13 and 14, part of this passage. So let me read it and explain. It says an ideal liquid of density rho is filled in a horizontally fixed range which is fitted with a piston. There is no friction and cross-section area of the syringe is known to us, and a small orifice is made at one end. When the piston is pushed, liquid comes out of this orifice and find the parabolic path to go to hit the ground. So this is the situation. I have assumed this point to be 1, this point to be 2, this point to be 3, and the velocity of point 1 is going to be very negligible, so v1 is going to be tending to 0 for practical purposes. Velocity of 2 point when the liquid is coming out from this small orifice is v2, and when it hits the ground is velocity, at that time velocity is v3. To solve it, let's say for question number 13, which says with what velocity does the liquid comes out of the orifice. That means we need to find the velocity v2. So we can go Bernoulli equation between 1 point and 2 points. So using Bernoulli equation between 1 and 2 points, we know Bernoulli equation is basically mechanical energy conservation equation, and it requires non-frictional forces to be absent, or frictional forces to be absent, non-frictional forces to be there. So and it also requires the liquid to be ideal, so this is ideal. It also requires streamline flow, so we will assume that the streamline flow is there and friction is absent, of course. And Bernoulli equation states like pressure energy per unit volume, kinetic energy per unit volume, gravitational energy per unit volume, sum remains constant. So this is for point 1, this is for point 2, both must be equal. Now we need to find what is the pressure at point 1. So pressure of point 1 is going to be the same as the pressure which is outside, that is P0 plus extra coming because of this force. So one pressure is going to be P0 plus F by A. V1 comes out to be 0 or close to 0, so we can ignore it. And from the ground, this one point is at a height h, so we are taking this point at the same level. So that's a rho gh. Pressure of the 2 point which is in the atmosphere is going to have pressure P0. Velocity is V2, so it's going to be half rho V2 square. And it is also at a height h, so it's going to have a rho gh. You'll find rho gh get cancelled out, P0 gets cancelled out. So from here you will find this term and this term will be remaining. And if you simplify this, you'll find V2 is going to be equal to square root of 2f by rho A, which matches with this option B perfectly. So B is correct for 13th. 14th asks with what velocity does the liquid strike the ground. That means we need to find the V3 value. Again, we can apply the Bernoulli between 1 and 3 or between 2 and 3, or we can go for a projectile motion from 2 to 3. So from either way we can find it out. Here for question number 14, I have used Bernoulli equation between point 1 and point 3. So pressure at the point 1 we have already calculated is P0 plus F by A, and the second term was 0 and the third term is rho gh. At 3 point we will find pressure is going to be P0 and the kinetic energy will become half rho V3 square, and potential energy term will be 0 because height of this point from the same reference is 0. You will find P0 is getting cancelled out, and half rho V3 square comes out to be this cross multiplication, that means F plus rho gh A divided by A. From here V3 is going to be equal to 2 times in the bracket F plus rho gh A divided by rho A, and this is within the square root. And if you match, then we will find this D option is going to be matching correctly. So hence D becomes the correct response. This is how we can answer 13 and 14 based on this passage. Okay, thank you.